Yeah, today's NAT. And so, of course, NAT was the solution that was made back in the 90s when they realised that the addressing scheme was going to run out. Well, we've got 20 years out of it, and still going. So, pretty good for a quick patch job, basically. But of course, it does have its problems. It sort of does break end-to-end connectivity, adds complexity, and a whole pile of other things. So, of course, at home, basically your router is going to be running NAT whether you like it or not, pretty much, because you only ever get one IP address from your ISP. And so basically it's built in. It's pretty hard to not have NAT on one of your home routers. Of course, with the Cisco router, it's up to you where the situation you install it. So that's why we've got to configure it when we need it and not configure it when we don't need it. And so, of course, when it comes to NAT, there's several sort of flavours of it, which I'll demo today. And so there's Static NAT, and so basically if you have a server that needs to be accessible from the outside world, you can actually make a one-to-one relationship between an external IP address, or a public IP address, and your internal private IP address. You can do that. Then of course there is a much similar solution. It's called port forwarding. So you can do that with Cisco router as well. That's normally the option you've got for your home routers. You've often got port forwarding as an option as well. And so, of course, basically what that does is if someone connects to your router's public IP address using a certain port number, it will then forward that information according to your mapping that you've made to the internal host that you've mapped to it. And so I'll demo it with a port 80 web server, but so you can look at pretty much any port. And so I'll be demoing that as well. And then of course there's the Dynamic NAT that we use for the clients to connect to the outside world. And so there's two options with that, NAT and PAT. Of course, PAT is port address translation as opposed to network address translation. So NAT, using the true sense of the word, is actually a one-to-one relationship between internal private addresses and external public addresses. And so you need a pool for more than one host to be able to connect to the outside world. And so I will demo that first up, and then I'll actually change the config to take in PAT. And so in that instance, I'll actually just use the public IP address that's available on the router and share that amongst the hosts using PAT. So of course PAT uses addresses and port numbers, and so that's how you get your one-to-many relationship between public IP addresses and internal private addresses. Because it's port number, it's a 16-bit number, so you've got over 65,000 options, but you're not going to get 65,000 hosts out of that, because how many of us only have one connection going through a firewall? Not many these days. So typically the relationship that most people apply is 4,000 to 1. So 4,000 internal hosts can share one external IP address. Pretty good ratio. But yeah, certainly not 65,000. And so I'll demo those things today. Cool.
Now, so I've got a bit of a setup here. Oh, I didn't decrease its size. So I've got an ISP router, and there's just a server there available as a target for making all kind of connections through the NAT translation. And so R1 here is the router that we will be using for the NAT router. And so we've got R2 and R3 hanging off here, and that's where all our clients are installed. We've also got some internal servers that we'll use for Static NAT and also that port forwarding as well. So we'll set that up as well. And so, of course, the host will need that Dynamic NAT or PAT to get out of the network to the world. And, of course, the Static NAT is how we can connect into these hosts from the outside, the outside world. All right, so the config. So the first part is the interfaces. Because we have a combination of inside and outside interfaces. The router needs to be oriented so it knows what's inside and what's outside. And normally you will have one outside interface, in this case serial S01. So if I hover over this, it's that one. And then we've got the two internal interfaces, which of course are the ones that go to the other routers. So you only need to do that once, and as long as your outside interface doesn't change, you normally leave that pretty much alone. Now, we're going to look at Dynamic NAT to start with first. So one of the tasks you need to do is you need to create an access control list that will basically define what internal hosts will be allowed to make a NAT translation. Now, if you notice the addressing on this packet tracer here, we've got 192.168.10, 20, 30, and 40. So we've got multiple C-class addresses available. I could have actually just done a line for each one of those and that would have worked perfectly well. But I thought I'd use the wildcard and be a little bit lazier and do less typing. And so, of course, I suppose I could have made it a little simpler. If I started at 0 and went through to 3, I actually could have had a different mask and been a little more precise. But anyway, so, of course, bit of revision for our access control list, of course. You need to supply a sample address. And, of course, this is it. This is a standard ACL. So 192.168.0.0. And then here, of course, here's the wildcard mask. And of course, wherever there's a 0 in the mask is, and of course, we need to reduce that back to binary. That is, of course, where the bits need to match, must match for an ACL. And where you have a 1, of course, that means that's where you don't need to match. Now, what this wildcard mask is saying here is none of the 4th octet needs to match. Of course, that's the host numbers within the networks. And what the 7 says is basically 7 is 4 plus 2 plus 1. So the last 3 bits of the 3rd octet don't need to match as well. And so when you've got networks 0 through to 7, basically would match this ACL. So that's why I've done it that way. As I said, I could have done it, if I'd started at 0, I could have actually done 003 to 55, and that would have worked, but oh well, whatever. Now, because initially we're doing Dynamic NAT, which of course is that one-to-one relationship, we need to define a NAT pool. And so I've done IP NAT pool, called it LANs, just because there's multiple local area networks. And then from there, I've given a range. Now, of course, this pool of addresses need to be public IP addresses. And so, of course, if you look at the host here, let's select that. And you can see that it was S010 was the outside interface. And of course, that's got an IP address of 10.0.0.2. And of course, the ISP's one is 10.0.0.1. And so basically, and it's /24. So there's a total of 254 usable host addresses. And so I've just grabbed a pool of, well, 21, I suppose, 5 through to 25. And that's the pool that's available. So with this solution, at any one time, 21 hosts on the inside network can connect to the outside world. It's not great on most solutions, though, is it? It wouldn't last long in this building. But yeah, that's what I've done. And so that's basically, I've now defined the inside global addresses here, inside local addresses here, and I've defined the inside global addresses here. Now we need to tie them together. And so that's what this IP NAT command does. So it's IP NAT inside source. And so it's the source, of course, that creates the translation. And so we're using list 1, which of course is access list 1. And we're using the pool called LANs. And that ties them together. So now it makes that relationship between those inside globals and the inside local addresses. All right, so the next 2 lines are those static assignments that I was talking about. And so what I'm doing is I'm using 192.168.1.20, which is this server here. I'm making a static assignment for that so that outside hosts can connect to that server. And so if they use the IP address 10.0.0.3, they will actually be able to connect to that host there. So the router will do the translation and send it to 192.168.1.20. And so, of course, 1 is used by the ISP router, 2 is used by the R1 router, and so 3 was the next available address. That's why I did that. And of course, that's why the pool started at 5, just to give me a bit of space. Now, then this last command here is actually doing that port forwarding we were talking about. So it's similar to the previous command, except because we're talking about port numbers, we need to specify what port numbers. And so, of course, it's either got to be TCP or UDP that use port numbers. No other protocols do. And so, of course, I'm talking about a web server, so it's TCP. And so the inside local address, of course, is 192.168.4.20. So that's actually this server here. It's a web server, so it's listening on port 80. But basically, if they connect to R1 with the address 10.0.0.2, wishing to use port 80, it will actually, the router will then translate that destination to be 192.168.4.20, again with port 80. So that's the translation that will happen. So, of course, this static NAT here is for all ports. So you've exposed the entire server to the outside world. You might actually want to have some ACLs defined on the router to control what ports can and can't be used. While with this one, there's only one port that can be used, and that's port 80. So you could actually, instead of doing this all or nothing type solution, you might actually just do several of these. You know, if it's a DNS server as well, do port 53, UDP, port 53, things like that. So that's what you could do, but yeah, there's more than one way to make the solution, basically. So I'll grab the config and paste it into the router and have a look at what goes on. Pasting away. I don't see any errors, so that's nice. All right, so let's ping the server. So I've already prepared the command. Why would I type it? All right. Might be the odd ARP request happening first, but we have success. Do it with the other host as well. That's working. Let's do it with another host as well, because I can. All right, let's have a look at the router. And so there's, of course, the command show IP NAT translations. And basically every ping packet that I sent gets its own translation, because it's not TCP or UDP, it's ICMP. And so you'll notice that I did pings from 3 hosts, and so there's probably, yeah, there's 4 from each one of those hosts. So there's 12 translations. And so as you can see, here, the first host used 10.0.0.5, of course, the first address of the pool. The next host used 10.0.0.6, the next address in the pool. And so we also used 10.0.0.7. And so they're the translations that happened. We haven't looked at this yet, and so you can see the static translations as well that are there sitting there. So of course that's that static, the normal static one. And this is the port forwarding translation there. So that worked nicely. Now we've got those static translations as well. What I could do, I suppose I could do something else with the host. I could web browse, couldn't I? And so that worked as well. So if we go back to here, do the show IP NAT translations, well, those others seem to have timed out. But we're actually using IP address 7, and away we roll. So you can see that it used port 1025 as a source port, and of course the destination port was port 80 because it was a web server. So you can see those translations that happened. Now, if I use 10002 from the outside, I actually should awaken this translation. Copy. So of course this has a web browser. Now what I've done with this, so that's the port forwarding one that I've done. And so you'll notice that I've actually changed the web server to actually tell me which server it was. And so of course I did 10002. If we go back to this, that's the address I typed in. Of course it's gone to this web server. So that's all good. That's the way it should be. Now, if, oh, I've closed it. If I do 10003, of course it should do the static one that I've done to that other server. Copy. And as you can see, it's because I've put 10003 in, it's actually gone to 192.168.1.20. Now the difference is this first one, if I FTP to 10003, it should actually work. Because I've done a static one for all ports. And so from memory, it's user and password. And I'm into FTP. So I'm actually using the FTP server on that server. And so I'll quit. I don't really want to do that. Now, if I do that FTP, but to port to address 2, of course, I haven't done the FTP translation here, so this should fail. And it does, even though this server actually does have an FTP server running. Where are we? It is running. It's exactly the same setup as the other one. So I suppose I could actually just use FTP from here to test it. So if I FTP 192.168.4.20, it is actually an FTP server. But because there isn't a translation for the port number, it didn't work from the outside. So I'm in. Oh, that's right, it's quit, isn't it? So that's, so we probably could do a show IP NAT translations again. And so you can see that the translation has actually been active for that port forwarding. And you can also see that there's been these connections to both the web server and the FTP server go through the NAT as well. That's all very nice. What's this one? Ah, it's an outbound. All right, now. So we've tested NAT and it does seem to be working, but of course we're using this LAN pool, which is sort of, less than ideal. So what I thought I'd do is I'll actually change it to PAT instead of NAT. Now, before I can actually change anything with the dynamic NAT I need to clear all the translations because there are some still active ones. It actually won't let me kill that translation. So I actually have to go in here and clear IP NAT trans star, which kills all the translations. So I can do a show just to make sure that only the statics are in there now. That's cool.
clearing it is from privilege from the.
Yeah, yeah. And so I've basically got this command here that will get rid of this command, get rid of that translation, and then a new translation. So the source list is still the same. We're still using the same access control list. But instead of using the pool lands, I'm actually using, here, the IP address from S010. So that's the public port or the outside port on the router. Now, the reason why I can specify the interface is, well, you know, when you connect to your router, connect to your ISP, you'll often get a different IP address every day or whatever. And so if you can codify the interface, well, then it'll just grab whatever IP address is active at the time. Now, overload is what changes it from NAT to PAT. And so basically all the inside hosts will be sharing the IP address from this interface. They won't be able to use port 80, of course, because that will be used, but inside hosts rarely use port 80 to connect to the outside world. So copy. So I've gotten rid of the NAT translation. I've created the PAT translation. It's all saved. It's all good. All right. So if we do show IP NAT trans now, of course, there's only the statics because no conversations have happened since I cleared the translations. 10.1.0.2, isn't it? .1.0.2. So all these hosts can get to the web server. Let's see what translations are happening now. So now you can see that they're all sharing 10.0.0.2. So there's the static one here and of course the static one there, but all those web servers all use that. Now, you'll notice that two hosts actually use the same port, the source port number, 1026. None of them actually use 1024 themselves, but the router basically translated the port number so it would be unique. So they're all talking to the same destination host, so that is imperative for identifying which conversation is going to which host. So that's why I had to change the port number from 1026 to 1024. All right, so of course the static would still work. So we have a whole pile of translations going on. So that is the inbound translation through the port forwarding. So that is pretty much all I was planning on for NAT. There's not a lot else we can do. I've done all the options there. Now these files are up on the Cisco server under demos and slides. And so, yeah, you won't be tested on this in the practical sense until the end of the semester, this particular topic, as well as last week's topic. What did we do last week? ACLs. So, yeah.